Welcome to Word Problems with Ratio Answers. Recall these rules from Chapter 5 for solving word problems using conversions. Write the wanted unit first, and if the wanted unit is a single unit or a single unit per more than one of another unit, then write the wanted unit as a single unit. If, on the other hand, the wanted unit is 1 unit per one other unit, then write the wanted unit as a ratio, that is, as a fraction with a top and a bottom. We write the data as single units or as equalities, not as ratios. So in problems that can be solved using conversions, most of the data will be two measurements that are paired because they are equivalent in some way. And paired measurements are written in the data section as equalities. So if we want a single unit, then a single unit amount from the data will be used as our given. And the rest of the data will be paired measurements. So those measurements will be paired into equalities. On the other hand, if we want a ratio unit, then all of the data will be paired measurements. They'll all be equalities. So there are multiple ways to solve for ratio units using conversions. The first way requires us to add another rule to the above list that we have. And that rule is to solve in choosing a given. If you want a single unit, then we need to start with a single unit. If you want a ratio unit, then start with a ratio. And this rule is based on the law of dimensional homogeneity, which says if a single unit amount is alone on one side of an equal sign, then a single unit amount must result on the other side of that equal sign. If a ratio unit is on one side of an equal sign, then a ratio unit must start and result on the other side. And if you don't follow the law of dimensional homogeneity, then the two sides of your equal sign cannot be equal. So if you want a ratio unit, it doesn't matter which ratio from the data that you start with. Remember that order doesn't matter in multiplication. So it doesn't matter which one that we're starting with here. But it is possible to pick a ratio as the given which won't cancel to give the wanted ratio unit because the given is upside down. And if you find a case like this, then start your calculation over again, but invert your given, which means flip your given over. So what you had on the bottom, put that on the top, and what you had on the top, put that on the bottom. So let's look at some methods that will help us to pick the given ratio that is right side up the first time around, so we don't have to bother going back and flipping. So method 1 is start with one given unit where it is in the wanted unit. So to solve for a ratio unit, pick your given from the equality in the data that includes one of the wanted units. And place that wanted unit in your given ratio where it needs to be on the top or the bottom in the wanted unit. And this way, you don't need to convert that unit, and you know your ratio is right side up. You only need to convert that second unit. For example, if a car is traveling 60 feet per second, what is its speed in miles per hour? Well, the wanted is a ratio unit. We want to know miles per hour, the speed of the car. The data that we have is 60 feet equals 1 second, because we know the car is traveling 60 feet per second. This is per 1 unit, so that means we can write that as an equality. And we also know that 5,280 feet is equal to 1 mile. Now, I didn't write down here in the data section conversions from seconds to hours. I'm assuming that you know what those are at this point. So we can use method 1 to write our given ratio that includes one of our two units in the wanted ratio. So we want miles per hour. So let's start with miles on the top. So we'll start with 1 mile from our 1 mile equals 5,280 feet. And we'll put 1 mile on top, and then we'll put 5,280 feet on the bottom. And now we know that we have miles where we want it, so we're not going to touch that. All we need to do now is change from feet to hours. And now we can finish solving using conversions. So we already had 1 mile on top and 5,280 feet on the bottom. We want to get rid of feet, so we need feet on the top. And we have a way of getting from 60 feet to 1 second. So we'll put 60 feet on the top, 1 second on the bottom. And now our feet cancels. We have miles where we want it, so now we have miles per second. But we don't want miles per second, we want miles per hour. So now we need to get rid of seconds. So we need to put seconds on the top in the numerator, and we'll put 1 minute on the bottom. So 60 seconds is equal to 1 minute. But we still don't have miles per hour, we have miles per minute. So we need to get rid of minutes here and get to hours. So now we finally have our correct units, miles per hour, and when we work out the math, this ends up being 41 miles per hour. So method 2 is to arrange the given based on complete labels. So another way to pick our given ratio, that is right side up, is to include complete and descriptive labels after the units in the wanted and the data section. That is, use words to describe what the unit is measuring, and then pick and arrange the given to match the labels in the wanted unit. For example, if a 250 milliliter solution contains 0.020 pounds of dissolved sodium chloride, how many moles of sodium chloride are dissolved per liter of solution? And we're given that 1 kilogram is equal to 2.20 pounds, and 1 mole of sodium chloride is 58.5 grams of sodium chloride. We're given that molar mass. So let's write our wanted and data sections with descriptive labels. So we want moles of sodium chloride per liter of solution. So this sodium chloride and solution there are the descriptive labels that we're adding. We're not just saying we want moles per liter. And then in the data section, we've got 250 milliliters of solution is equal to 0.020 pounds of sodium chloride, because we were told that that was the mass of sodium chloride we had dissolved in 250 milliliters of solution. We also then have down here our other two conversions that we were told. We were told that 1 kilogram is equal to 2.20 pounds, and we were told the molar mass of sodium chloride. So we need liters of solution in the denominator of our wanted unit. Here, we want liters of solution. And thus, for our starting ratio, let's put a unit that pertains to our solution in the denominator. So down here in the solve section, we want liters of solution, so let's start with 250 milliliters of solution. We're still going to have to convert from milliliters of solution to liters of solution, but we know how to do that, and now we know for sure that that milliliters is in the right place. So now we just need to apply conversions in order to solve. So we have what we started with on the last slide, the 0.020 pounds of sodium chloride over 250 milliliters of solution. And now we'll convert from milliliters of solution. We want to get rid of milliliters because we want liters of solution. So we'll get rid of milliliters here, and we'll be left with liters in the denominator. And this is still going to be liters of solution. So now we have 0.020 pounds of sodium chloride in 0.25 liters of solution. And now we want to get rid of pounds because we want moles of sodium chloride. So we need to get from pounds of sodium chloride to moles of sodium chloride. So we get rid of pounds of sodium chloride here, convert to kilograms, and then we convert from kilograms to grams, and then we can convert from grams to moles of sodium chloride. And so now we have moles of sodium chloride on top where we wanted it, and we have liters of solution on the bottom. And when we work out the math, it ends up being 0.62 moles of sodium chloride per liter of solution. So method 3 is to arrange the given based on dimensions. That is, we can also pick our given ratio such that the given dimensions match the wanted dimensions. For example, suppose that kilometers per second is wanted and 24 miles per hour is in the data. Well, we want a distance over time, and thus we should start with a distance unit over a time unit. So we want kilometers per second, that's distance over time. We have a distance unit here, we have a time unit there, and thus we can start our calculation by putting our distance unit, 24 miles, over our time unit, 1 hour. And then we can go on and convert from miles to kilometers and from hours to seconds. So now let's talk about ratios that are represented by negative powers. Ratio units can be represented in a few different ways. We can represent it as A per B, or as A/B, or perhaps as A over B, or as this way, A times B to the power of -1. And when you see that third representation, that A times B to the power of -1, then you should mentally switch it to A over B, or A/B. That is, that A times B to the -1 is a ratio unit. For example, grams times moles to the -1 is the same thing as grams per mole, or grams over moles. And note that sometimes you may see negative exponents other than 1. And these are treated in the same way, except that the absolute value of our exponent must be kept as the power. For example, grams times centimeters to the -3 should be treated as grams divided by centimeters cubed, or grams per centimeter cubed. So that was word problems with ratio answers.